Let's get started. So firstly, just to introduce myself, my name is Joe Fletcher. I work for 1AV in technical sales. My sort of specialities are kind of the more in-depth project planning side of things. So after this, if you've got any questions or need help with anything in general, just give me a call. That's what we're here for. I'd like to think it's kind of what us at 1AV we sort of specialize in. We're not really a box shifting business. We like to get down and dirty and get involved in the project. So yeah, give us a call if you've got any questions after this. So today's webinar is about Cel-Fi. Cel-Fi is a very unique product to us, and I think it's something that really is unique to 1AV. And it is something that we have seen grow year on year as we find it really adds a new element to sort of the CI industry, and potentially it's a product that you guys could be speccing into your products that you might not have considered speccing. But there's certainly a lot of opportunity there, and we've seen that in how our sales of Cel-Fi have grown over the years. So today there's a few things I'd like you to sort of leave knowing. And I'm going to say this again and again, what I will be trying to hammer home to you is how important it is to plan early and get cabling in early for this, and how much easier that was going to make your life down the line. So today we discuss why mobile signal is part of most projects, how to identify the opportunities, why coax planning saves time and protects your margin, how it works, best practices for doing surveys and installing it, a quick overview of the products. This isn't a salesy pitch. I'm really focusing on the technical aspects of it. And in fact, there isn't really that many products anyway. You've just got a couple of things you can put in that do similar jobs. There's just different ways of doing those jobs, how to position it, and finally, how we can help you. So why is it part of every project? Well, obviously it goes without saying that your clients expect mobile coverage everywhere, and that, in our experience, is actually with the way houses are built nowadays, is an unreasonable expectation without some additional hardware. And we get common complaints of drop calls. The other one's call handover being poor. So that is the call handover is the ability to move from location to location and maintain a signal. You might find you have signal in one place of the property, but as you go deeper into the property or downstairs or upstairs, you lose that signal. That's called handover, and that can tend to be very poor. And it matters, for security reasons. Mobiles can more. The amount of time, all those texts you get from your bank saying, "Is this you? Have you signed in here?" Often those texts don't work over Wi-Fi calls. They're not allowed there because they use the SMS network. And modern buildings are making this problem worse. We're not expecting anything to change anytime soon in terms of how buildings are made to make mobile phone signal better. So the large problems, there's concrete and steel structures. Foil-backed insulation is a real killer. That is very bad. And the new methods of doing double and triple glazing are also really bad for mobile phone signal. So the opportunity for you as we see it is just something else you can offer in your portfolio of services you offer your clients. It needs to be something that we want you to think every project you go into, in the same way when you go into a project, you're thinking about opportunities for networking, you're thinking about opportunities for audio distribution, you're thinking about opportunities for video distribution. You should also be thinking there is an opportunity here to improve their mobile phone signal, or at least offer them a solution. Maybe they don't go for it, but at least you should be offering it. So Wi-Fi calling, one of the most common questions you get is, why wouldn't you just use Wi-Fi calling? And the reality is that Wi-Fi calling has some consistency issues. It doesn't really support handover very well. It's interesting. Some phones can handle it better than others. It's actually down to the phone manufacturer how well they can handle going from access point to access point. And the thing is, often you'll have blips in your Wi-Fi coverage anyway. Now, for Wi-Fi and internet, it doesn't matter so much. If you go from one location to another, your customer isn't necessarily going to notice that their network speed dropped for a little bit. Whereas if they're on a phone call, they will notice that problem, because the phone quality will either drop out entirely or at least become unlistenable. And that is something that they might blame on you. You're responsible for the install in their house, so that should be something you're covering, or at least offering them an option to cover. So this is the big one, planning early. most of the times when we've had projects fall over, where we hit a point where we can't provide a solution for a project, and I would say 95% of the time, it's down to us not being able to get coax in early enough. So I'll go into this in more detail later, but with Cel-Fi, there is always some amount of coax involved. There will always be a run of coax from an antenna to wherever you position your main comms location. That always, no matter what product you use, that's always going to exist. So that you'll always have to have that cable run. And then the next cable run is the distribution in the property. Now, there are solutions that don't need coax for distribution inside the property. Those are much more expensive than the solutions that do use coax inside the property. And you might find that the CAT solutions are cost prohibitive, whereas if you'd had an opportunity to run coax earlier for the distribution, actually it may have fit your client's budget. So we always try and encourage people, get the cabling in early. If you're involved in the first fix in the property, raise the question, might this customer want mobile phone coverage later, or a mobile phone boosting solution? Because it's very easy to get that coax in early. It is not easy to get that coax in late. This isn't your normal sort of coax. It's 50 ohm coax, so it's much thicker, much lower bend radius, and is not easy to retrofit. Not impossible, but not easy. So when you're planning for your coax, if you haven't got all the information about the property, ideally what you're going to want to establish is make sure you've got a runs of coax, potentially if you've got multiple networks, from the comms rack to wherever you would put an antenna. And normally that antenna position is fairly obvious. There'll be other stuff going into the property. You'll have your satellites and things like that. So probably going to be going to the same location. Donor antennas. So those are your external antennas. Then you've got coax indoors. So obviously it's hard to tell exactly where you're going to need boosters indoors, but it'll probably be a safe bet to have at least one run of coax going to each sort of primary location. And when I say primary location, I mean living rooms, kitchens, bedrooms, and stuff like that. Pre-wire key coverage zones, again, that's what I've just said. And allow any spare capacity. You might want multiples of these cable runs. If you're going to run one, it can be very cheap just to run multiples, so you've got some redundancy. So how do you position it with your clients? The big one is that this is completely legal. Mobile phone boosting has a little bit of a reputation for being, I guess, dodgy. That there is some truth to that. Initially, a lot of the boosters that were sold into the UK were not Ofcom approved. So early on, sort of 10, 15 years ago, there were some, I guess you would call dodgy Chinese boosters sold into the UK that didn't meet Ofcom regulations. And those people who installed those were hit with some fairly hefty fines. That is not the case with Cel-Fi. It has full Ofcom approval, so it meets all the requirements and is completely legal. The second thing to understand is it's hardware based, not subscription. The reason I mentioned subscription is there is a competitive product in the UK that their business model is based on a subscription. So the idea being that you never own the hardware, you just pay them a monthly fee, and then you get your coverage. That's fine, and there are some situations where that cost-wise that might make more sense. But the reality is with Cel-Fi, once the Cel-Fi is paid for, they own it. It is theirs. It belongs to them and in their property, and so it increases the value of their property because they have this hardware installed. It's not dependent on Wi-Fi calling whatsoever. It doesn't touch Wi-Fi in any shape or form. It's what we call an on-air repeater. So you're taking the signal that is already outdoors and bringing it indoors. And because you're doing that, it makes it reliable. So what that means is if you're outdoors on a call, when you go indoors, the signal you're getting indoors is exactly the same as the signal outdoors. So there is no handover from your mobile phone. It'll be seamless. And yeah, as I said, add long-term value to the property. You are installing something, if a property has issue with mobile phone signal, that is never going away. It will always have those problems. There's no changes you can make, and there's no planned rollouts in the UK for new frequencies being covered that wouldn't have this problem. If the property has bad signal, it's always going to have bad signal. So yeah, in terms of maximizing your margins, as I said before, and I'm going to keep hammering this home, quote it early, get it in, get the infrastructure in. It is much cheaper to install this sort of thing, and you can use cheaper options for hardware if you get an opportunity to put cabling in early. We can offer a survey. So this is something you can do yourself or we can do for you. But it's possible to survey for mobile phone signal. So that is produce a document that gives the customer a detailed guide to sort of where their problem areas are in their property, where there's poor signal. And then based on that, we can make recommendations about hardware that should go in, and it reduces uncertainty. So there's no sort of last minute cables being pulled or anything like that. We know where we're going to need them, and avoid the retrofit costs. As I said, this is a product that does not lend itself amazingly well to retrofit. It's not impossible. We can do it, and we've certainly had projects where, we've had a project where we knew about it 2 days before it needed to go in, and we've provided a solution in 2 days. It was an expensive solution, but it was the only option based on what we had available to us. So just talking about the compliance quickly, just to give you a very quick overview about this. I don't want to get too bogged down in this, but mobile boosting is highly regulated in the UK. Cel-Fi is carrier approved, license exempt. Don't install illegal repeaters. I'll explain why shortly. And obviously compliance, it protects your reputation and reduces any risk you yourself might have. So these are the Ofcom regs in the UK. It's called UK Interface Requirement 2102. If you want to Google that yourself, if you're curious, you're welcome to, but we're not going to go too much into that today. But essentially the page looks like this. And what this does is this gives a very detailed list of all the requirements a mobile phone repeater that is sold in the UK needs to meet to be Ofcom license exempt. Suffice to say, Cel-Fi meets all of these. In fact, Cel-Fi in the UK is manufactured to meet these standards. The way this hardware works in the UK is different from other parts of the world. It's made specifically to work within the UK regs. So what's the problem with illegal repeaters? Obviously, they're not approved by the carriers. But the big one is they cause interference. So just if I can explain to you quickly, with a repeater, what you're doing is you're taking the signal indoors, you're putting it into an amplifier, you're increasing the strength of that signal, and then you're broadcasting it again indoors. Now, the problem with illegal repeaters is what they do is they don't monitor how heavily they're boosting their signal. So what ends up happening is the signal indoors becomes so loud that essentially your external antenna starts picking up the internal signal stronger than the external signal. And what this causes is a feedback loop. So it's exactly the same as when you're at a concert and you hear that high-pitched sound coming from a microphone, because the sound from the PA has been picked up with the microphone. It's just looping over and over again, increasing in pitch each time. The exact same thing happens with mobile phone signal. And that basically what happens is that can cause massive problems for local emergency services. So if you've got a booster in your property that is behaving this way and is feeding back, the way that gets noticed is police cars and ambulances that drive in that location notice that their communication equipment stops working when they're in that location. Then they file a report to Ofcom. Ofcom come and look at it. They come in their van, they drive around with a testing kit, and they find the property that has the illegal repeater, and then they find out who installed it, and then they issue a 5-figure fine to that company for installing that illegal repeater. The way Cel-Fi works is Cel-Fi is almost, I'm a music guy, so this is an example I use, but Cel-Fi is like a sound engineer. So a sound engineer's job at a concert is to basically make sure that none of the microphones are feeding back. So they monitor the volume, and then anything that's getting too close to feeding back, they turn it down. That's basically what Cel-Fi does. So it gets the signal, it starts boosting it, and then it monitors if there is any feedback. And as soon as it detects that there's feedback, it dials back the strength of the boost, the signal that's been boosted indoors. So essentially you never get this feedback effect, and that's why it's called a smart repeater, because it's monitoring itself, it's checking that it's not doing anything it shouldn't be doing, and it makes sure that no feedback is caused and no issue is caused on other frequencies. So just a little nitty-gritty. So in the UK, We use 4 different bands to broadcast mobile phone signal. Band 20, band 8, band 3, and band 1. And the 4G, 2G, 3G, 5G signals are all split over those in some shape or form. You don't really need to know this. It's just good to have the knowledge. But the Cel-Fi equipment will pick the best one for you in your install. So when you configure it, you can choose which bands you want. But if you don't want to bother doing any of that, it will just detect which ones it thinks are best to give you the end result you want. The end result here is your customer having good phone signal, and it will do its best to find the best options for providing that result. So 5G, just going to talk about this very quickly. Obviously, the 5G rollout is gradually happening over the UK. We're seeing it more and more. 5G doesn't do anything to help with poor signal problems. 5G is purely about speed. It doesn't penetrate any better than previous 4G and 3G signals. In fact, if we wanted these problems to go away, the best thing we could do is to put 2G everywhere. 2G operates on a lower frequency, has better penetration. But yeah, 5G doesn't fix that. 5G is just about having faster network speeds, not improving coverage. Yeah, so yeah, 5G is 10 gigabits theoretical, but that's only if it's working well. And 5G is, say, it's on a higher frequency, and there are some new bands rolling out in the UK, but these bands are all at higher frequencies, and higher frequencies penetrate worse. So none of this is going to help with the problem of having good mobile signal. It's just going to give us better mobile signal speeds. So why would you want to conduct a survey? Well, there's a few reasons. The main one is, and the most important, is making sure that where we position our donor antennas, so that's our external antennas, we're getting the best possible signal. The better signal we have coming in, the better the indoor performance, which makes sense. We're taking something outdoors and bringing it indoors. So maximizing the quality of that signal is really important. We confirm the feasibility. So this is really important. We need to see if we can actually achieve what we want to achieve. Sometimes we get properties where we can't achieve what we want to achieve. I had one last year where, with the best will in the world, I went there, we looked around, we looked at cable routes. It was a finished property, so we were trying to use the existing infrastructure. There was no opportunity to run any more because the house was closed up. And we looked at loads of different possibilities, but we just couldn't find a way to provide the solution. And that happens sometimes, but the important thing is that we came to that conclusion before selling the hardware, not afterwards. And that's really important to us. You know, we don't want to provide you with a solution, but then find later that you can't do it and then have to have the hardware back. So we knew before we'd even sold any hardware that it just wasn't going to be possible. We ensure the correct antenna placement. So within the survey, we will scan the local area and find the best positions. And obviously that reduces your install time. So we take a 3-step approach to our surveys. So step 1 is we do a quick quote. So when you come to us and you say, I've got a client, there's a possibility they might want Cel-Fi, or we're early enough in the install where I want to offer it as an option, what we will do is we will give you a ballpark. So the way we do that is, ideally, if you can provide us just with the floor plans of the property, we will sort of look at it and work out, in an ideal world, what would we put into this property. But at that point, we're not looking at if it's possible. We're just looking to see, you know, if we can put hardware in, how much hardware we put in. So we'll give you a ballpark. And often we'll quote a few different solutions. We'll quote like a single network, all the networks, cat-based, coax-based. You'll typically sort of walk away with 2 to 3 quotes of different options, so you can at least present that pricing to your client and go, look, is this in budget, and is this something you'd be interested in us pursuing further? The next thing we do is we do a detailed survey. So we will actually come to your property and do this for you, or we will provide you with the hardware. If it's not feasible for us to get there, we will provide you with the hardware and training to do it yourself. It's actually not that complicated. It's just, you know, you, in the end of the day, you're just walking around taking some readings, and then we'll produce a document based on those readings. And so there is the installation support. So we will pre-configure all your hardware for you so it goes in as easily as possible. So the tools we use something called the Cel-Fi Compass. So this is a product that's made by Cel-Fi. And what it basically does is, once we're doing you a full survey, we will get plans of that property. And then the way it basically works is we walk around the property and we take lots and lots of readings, and the Cel-Fi Compass then builds us essentially a heat map of that property and the signal indoors. That is the Compass XI. It looks like that. And we have one of those, and potentially we can also loan you one if it's not possible for us to come and do it for you. Then what we do is we look at the local ordnance maps and we find out where the local masts are. So we will actually look, and before we've even gone there, we have a pretty good idea of what directions those antennas are going to need to go in. If we can't get that information, or we don't necessarily trust this information 100%, so when we're actually there, we will take multiple antenna readings as well and just confirm what we thought we were going to do. But we always come with an idea of what's available to you and what direction everything's in. And normally we'll try and get some, here we're using Google Maps, we will try and get some sort of photos of the top of the property and just provide you with some guidance as to where you should be placing your antennas. And this is an example of the heat map. So here is a property, and as you can see, this is the readings for EE. And there's a guide down there, and what we're showing you is the approximate quality of the signal in these areas. So we can see that in this property, the EE signal it's okay, it's not great. This would be what we would call good enough. If the whole property was like this, we wouldn't necessarily recommend installing a solution. I think this property will be fine. The only caveat to that is how early we are. If we were getting this survey and actually the property hasn't got all its insulation in, it isn't finished yet, it hasn't had all its cabling done, we know that this signal is going to get worse. So it might be that depending on the stage of build, that this isn't good enough and we think this is going to get a lot worse. But that would be on a case-by-case basis. But in this example, we see that 3 network in this property is very poor. This property needs a mobile phone boosting solution desperately. Nothing will be working well here. And then what we'll do is we will provide, oh, thank you, Deborah, just give me some water. And then what we'll do is we'll provide locations where we would ideally like to put antennas. And if we've done the survey, we'll actually have confirmed those locations with you. The donor signal is everything. Making sure you have good signal. I'm going to use a sort of an old antenna guy phrase, but shit in, shit out, which means that if you have very poor signal coming in, that is all you're going to be boosting throughout the property. So we will do our best to get the best possible donor signal, because we know that if we do that, we can be a little bit looser with the internal boosting because we've got such good incoming signal quality. And height matters as well. We'll always try and get things as high as possible. And then once we've got the antenna placement, we're making sure we've got good separation, we're avoiding feedback, we're avoiding oscillation. That's all stuff that we'll handle, and also stuff that the Cel-Fi hardware itself handles and will give us some warnings if we're getting feedback or we're getting oscillation. But again, plan early. This is why we have surveys. So in terms of choosing your antennas, you've got a few options depending on the property and what's available to us. The main one is this panel antenna. So this panel antenna is a very discrete external antenna. And an example where we'd use this is if let's say we're in central London, and actually it's an apartment, but the signal outside, there's tons of signal outside. So we know that there's getting strong outdoor signal is no problem at all. In that case, we would spec this antenna. It's a panel antenna, it's discrete, it just goes on the wall, it will pick the signal up. There's no need for anything fancier than this because there's so much signal outside. If the signal's got a little bit poor, then we upgrade to this directional antenna. So this is one that we can aim, and we can aim it at the local mast, and we can use this to provide a better incoming signal if signal outside isn't great. If signal outside is really, really poor, we'll upgrade to something called this. This is an LPA antenna. This is more for the countryside. So if we're right in the middle of nowhere, we've maybe got hundreds and hundreds of meters before we get to another antenna. This is what we use, pointed directly at wherever the local mast is. And as I say, we don't like to use these because they're not the prettiest thing. But sometimes, you know, if you want good signal, that's what you're going to need. So indoor antennas, can you use multiple indoor antennas? Yes, you can use as many as you want. With some caveats, you're limited by the amount of splits you can do, but we will provide enough hardware to get as many antennas as you need. And then you've got a few options for your antennas. So you've got your discrete antenna, and then you've got your dome antenna. As you'd expect with the discrete ones, their coverage isn't quite as wide as these dome antennas, but they're much easier to hide, and they're much less noticeable. Customers tend not to like these dome ones. We try not to use them. We try to use discrete ones wherever we can, but sometimes needs must. But most of the time we'll be speccing these discrete antennas for you because they're much nicer. Right, cabling. So again, I've hammered home about this, but let's talk about cabling because this is by far the most important thing. If you leave this webinar with one thing, learning one thing, I want you to understand how the cabling for Cel-Fi works. So you need to use quality coax. We sell quality coax. I don't mind if you buy it elsewhere, if you've got a supplier that you like to use coax already, but we need to be certain of the quality of that coax. So we like to see documentation on it because we can't guarantee a system performs well if we're not sure of the quality of the coax that's being used. So technically, what you want to be using is either LRM 400 or 600, depending on the length of the run. And lots of different manufacturers make cabling of that grade. We sell LRM 600 and 400. Other manufacturers do as well. But as long as you're using something that has that certification, you should be fine. Keep the cable runs as efficient as possible. So the shorter, the better. And we will help you planning routes to keep those as short as possible. Port termination, making sure you're terminating the cable properly. Very early on when we started doing Cel-Fi, we were having some problems and we realized that we just weren't crimping the cables hard enough. And it was as simple as that. You know, we were testing systems here and we were like, oh, these aren't really working well. But actually, when we looked at it and we re-terminated the cable and did a really good job terminating, suddenly the system worked perfectly. It wasn't the Cel-Fi's fault, it was our fault. We just did a bad job. And plan it early to reduce the labor cost. This is hard to stress this until you've worked with it, but LRM 600 cable is hard to work with. That's a very low bend radius. It's very thick. Even just getting it on a reel is a nightmare. So yeah, it is not easy to work with, but it is worth it. The system will work so much better with this cabling. And yeah, except for a very few, very sort of rare niche cases, you will be terminating this cable with N-type male connectors, which again we can provide you, or you can get them wherever you like to get them. But say we're more than happy to include these in the quote for you. But this is typically what we use. There's a couple of exceptions with certain products, but we'll deal with that for you. But this is the type of crimp you'll be using. And again, this is what the cabling looks inside. So actually, really, it's just a bigger version of the coax you're used to using for your sort of IRS systems and things like that. It's just much thicker copper, but that copper core is vital to maintaining the quality of the signal as you pick it up and bring it to the booster. So even though you might think sometimes the cable we're speccing is overkill, just trust us. After what we are now 7-8 years of doing this, it really matters, really matters. And again, if you know how to run any cable, you can install Cel-Fi. This is not complicated. Installing Cel-Fi isn't hard. If you've installed video matrix systems, if you've installed Wi-Fi distribution systems, if you've installed TV distribution systems, Cel-Fi isn't going to throw anything you haven't seen at you before. It's just thicker cable, but in terms of setup, it's very, very easy. So now I'm going to give you a quick overview of the products. So we're getting near the end now. So this is the G41. This is our most standard booster. So this is a coax only based solution, and it boosts one network. So in the UK at the moment, we have 4 networks, though that is soon to become 3 as Vodafone and 3 network are merging. I don't think this has happened yet. I think it's happened in some parts of the country, but not all. But the G41, essentially, you pick the network you want to boost, and then it will boost that network for you. And this is sort of our standard product. Comes in sort of trade. It's about 900-ish quid. And yeah, this is the one we sell the most of, and it's the one we do the most of. So this is just a standard booster. And then we've got its bigger brother, the G43. So very similar in principle. It's just this does 3 networks. And it also has 3 outputs. So the G41, typically, if you use a decent quality splitter, which again we will spec into your project, decent quality splitters, you can probably run about 4 to 5 antennas off the G41. With the G43, it does 3 networks, but because of the amount of output gain it has, you can run about 12 antennas off the G43. And their trade is around the sort of £3,500 mark. But there's obviously more hardware involved than just that. So a typical layout with this might just look like your donor, coax into the G41, and then coax off to the server antenna, and then that might split. So you might go to a 1x2 splitter instead. So you've got 2 server antennas providing your occupancy. This might be, a small house where actually the signal indoors isn't awful. So we might just put 1 antenna per floor just to improve it. An example of a bigger system to keep within budget might be something like this, where we want to do 4 networks, but we want to use G41s. Then you simply just give me an example of how you can work with Cel-Fi signal. So 4 different networks, 4 different G41s, all on different networks. That goes into this combiner, and then that combiner is then split. So all the networks are put into one, then it's split around the property. So Cel-Fi Wave. So the G43 and the G41 use something called Cel-Fi Wave, which is an app on your phone. So you connect to them via Bluetooth, and you basically configure them from there. So you choose which networks they're boosting. You can check everything's working. You can change anything you need to do on them. You can test them. You can do all sorts of stuff. But those use Cel-Fi Wave, and it sort of looks like this. I'm not going to go too much. It's honestly one of those things where once you use it, it's all very self-explanatory and it's very clear what everything's doing. So it's not worth really going into it too much. And you can just choose how to configure your system from in there. And it can give you some advanced details. So it can show you which bands are working, which bands aren't working well. So you can choose. And there might be some niche cases where you actually want to disable certain bands. The reason you might want to do this is just a little bit of sort of a tidbit of information from me. It may never come up for you, but there are some slightly weird things that can happen with your mobile phone when if you have 2 bands that are exactly the same strength, unfortunately our phones are a bit stupid and they can flick between bands. If a mobile phone will try and connect to the strongest band it can, there's a very strange phenomenon that can happen when you have 2 bands that are exactly the same strength, and actually it causes poor signal on your phone because your phone can't make up its mind about which band to connect to, so it keeps flicking between them. If we realize your phone's doing that, what we normally do is just turn one of the other bands off so it never gets that option. But again, that's not Cel-Fi's fault. That's just the phone manufacturer's fault for not putting sort of smarter software in to work out how to avoid doing that. So moving on to the Quattro range of products. So this is where we get slightly more involved and things get a little bit more complicated, but these are for much larger scale properties. So the Cel-Fi Quattro products, they're hybrid products. So they use coax to get the signal from outdoors to indoors. But then once you distribute it, you use cat cable. And even further from there, after the cat cable, you might start using coax again. So this is a much more involved product, but the amount of space you can cover is much, much larger. We would use this on, on mansions, on huge multi-story buildings. This is where Quattro really comes in. It's actually a commercial grade product. So it's designed for sort of massive multi-story buildings, for airports and things like that. But the reality is that some homes get large enough and complicated enough that you need this product. And there's 2 versions of it. There's the Quattro Evo, which covers 2 networks, and there's the Quattro 4000, which covers 4 networks. So the way a Quattro system works, so this is showing a very large project. is you've got your donor antennas. So those are connected to the Quattro, what we call the NU, which stands for network unit, via coax. And then from the NU outwards, we have twin Cat6 runs that go to what are called coverage units. So these coverage units are almost like stationary boosters that you can then do coax runs from to do lots of antennas. So in this example, we've got 6 coverage units, one for each floor, and those coverage units are providing coverage to multiple antennas on those floors. And there's some flexibility in these as well. So as an example, the cat runs that go to these CUs can be replaced by fiber. So there are some fiber extenders. So you might have a fiber extender going to a floor that's miles away, that's too long for cat runs, or it could be even a completely different outbuilding. This is something we see quite a lot in the UK, of doing massive properties where we've got a primary boosting system in the main house, but there's a, you know, there's a I don't know, a shed somewhere or a barn or somewhere that needs coverage that's, you know, a decent way away, and we can provide coverage to that location as well with a fiber extender. And similarly, you can actually do fiber to other NUs as well. So if there was we've done a project recently where there was an entire extra section of the property needed covering, where we did an NU, and then that NU connects via fiber to another fiber NU that was about 2,000 meters away, to a whole other separate system. So it's, yeah, you know, this is serious hardware at this point, and you know there is a price attached to that, but typically in the properties where they would want something like this, that isn't so much of an issue. And lastly, let's talk about how we can support you. So obviously I've given some examples of what we can do, but this is what we want to get across to you is if you've got a project or something you think you could be a Cel-Fi project, just call us and tell us about it, and we're more than happy to work with you on it, provide a quote, give you a ballpark, just get you started. If you've never done Cel-Fi before, that's absolutely fine. You know, a lot of our customers, we don't tend to get, you know, a lot of repeat Cel-Fi customers. What tends to happen is you just get that one project where actually it's really necessary, and it's something you can offer, and that's where we really shine and really want to help you with that. So lastly, is there any questions? Do the boosters need to be surface? So the boosters themselves can be hidden, but the antennas that are connected to them, ideally are surface mounted. That's not strictly true. That there's different ways you can do that. For instance, if they were in a cupboard, that would be fine because wood doesn't really impact the frequencies that they're emitting. And weirdly enough, neither do TVs. So often we can like mount them behind TVs and things like that if that's the space we've got to work with. So in an ideal world, yes, they are surface mounted. But if that's not an option, it's not the end of the world. We can hide them. And especially, you know, if for instance you're in an office or something and they've got ceiling tiles, then that's absolutely fine. There's no need for them to be visible. They can be above the ceiling tiles. I'd only be concerned really if they were sort of behind metal. That could be a problem, but otherwise it should be fine. Right, well, if there is no more questions, I will leave it there.